Alright, so let's consider this other question as well to explain translational mapping. So the question says translate the given mapping when given W to be equal to Z plus 1 plus 2I. Alright, so we've already explained what Z is. So this is a map. We are to translate this given map given this condition. So you recall that Z is equal to X plus I y. So this simply means that the condition given W is equal to, in place of Z is X plus I y. So we have X plus I y plus 1 plus 2I. So we have this. Okay, so this means that W is equal to, so I say at this point, you rearrange the equation, bringing together all the real terms or real parts, and then bringing together all the imaginary parts. So I have X and 1, these are the real parts, they don't contain any complex number. So we bring them together. We have X plus 1 plus, then I have IY plus 2I. So this I indicate that these two are what? Complex numbers. So you bring them together. Alright, so just rearranging a bit, this becomes X plus 1. Let's factor I. I is common between these two. So we have I into Y plus 2. So this shows now that this is the real part of this complex number and this is the imaginary part of the complex number. But not forgetting, recall I said always consider W to be equal to U plus IV. So which means wherever you see W, put in the value as U plus IV. There is W here. In place of this, we have U plus IV is equal to X plus 1 plus I into Y plus 2. So at this stage, you compare coefficients, comparing real parts to real parts, comparing imaginary parts to imaginary parts. On the left hand side of the equation, U is the real part, and on the right hand side, X plus 1 is the real part. So this simply means that on comparison, you have U to be equal to what? X plus 1. The real parts are equal, the imaginary parts are equal. Therefore, and V is equal to the imaginary part now, IV, I have IY plus 2. So I and I show that these two are imaginary parts. Therefore, they are also what? Equal. So V is equal to Y plus 2. I have this. Now, if we've obtained these values, we need to now translate this given map. To translate it, we start from the origin. At A is the origin, and at the origin, everything is 0. So at A, we have X to be equal to 0. Y is also equal to 0 at A, which is the origin. X is 0 and Y is 0. Then we'll find the values of the numbers, the U value of U and then the value of Y. So at A, X is 0. When X is 0, it means that U is equal to, remember, U is X plus 1 and X is 0. So it becomes 0 plus 1. And this implies that U is equal to what? 1, because 0 plus 1 gives us 1. Now, V is equal to, also Y is 0 and Y, V gives us here Y plus 2 and Y is what? 0 plus 2. So this implies that V is equal to 0 plus 2 gives us 2. Hence, at A, U is equal to 1, V is equal to 2. We repeat now, move from point A, which is the origin, to locate point B, and point B is found directly on the x-axis. From origin to point B is found directly on the x-axis, and total distance to that point is what? 2, which means we did not travel in the y direction to find 2. Hence, y is 0 and x is equal to 2. Okay, so at B, x equals 2 and y equals 0. So that means we are going to find u to be equal to, remember that u is what? X plus 1. X now is 2, so it becomes 2 plus 1. 2 plus 1, which implies that u is equal to 3. Y is equal to, remember, y is 0 and v is y plus 2. Sorry, this is v is equal to, okay, v is equal to y plus 2 and y itself is 0 at v, so we have 0 plus 2, which implies that v is equal to 2 because 0 plus 2 remains 2. Okay, moving from B, we move to C. Now, to locate point C, we move from the origin Now, you always move from the origin to locate each point. You move from the origin to locate B first, then move up to locate C. So which means I covered what? From here to this point, I covered 2 meters in the X direction, then covered 2 meters in the Y direction. So X is equal to 2 and Y is equal to 2 just to locate point C. So at C, X equals to, Y is also equal to 2. Therefore, U is equal to, not forgetting, we said U is X plus 1 and X now is 2. So we have, in place of X, you have 2 plus 1. This implies that U is equal to 3. V is equal to, also, V is Y plus 2 and Y now is 2. So you have V to be equal to 2 plus 2. So this simply implies that V is equal to 4 at C. Finally, we locate point D. From the origin, you locate point D. So you simply move from the origin down towards the Y direction in 3 meters. So you're moving from origin towards covering 3 meters to locate point D. So we didn't move in the X direction, hence X becomes 0. So at D, Y is equal to 3 and X is equal to 0. At D, X equals 0, Y equals 3. Therefore, U is equal to, remember, U is X plus 1 and X is 0. It becomes 0 plus 1, which implies that U is equal to 1. V is equal to, remember, Y plus 2 and Y is 3. So you have 3 plus 2 and that's equal to, okay, that simply implies that V is equal to 5. Okay, so we've gotten all the points. We now have to translate this given map. Okay, we can do that over here. All right, so this represents the V values or the imaginary values, and the X direction represents the U values or the real parts. So let's start our map. At A, we had U to be equal to 1 and V to be equal to 2. So let's pick out the values from the highest to the lowest. For U terms, I have 1, I have 3, I have 3, and I have 1. So 3 is the highest for U. So from the origin, you can call here 1, you can call here 2, you can call here 3. Whereas for V terms, I have 2 here, I have 2, 4, 5. 5 is the highest, so you can call here 1, 2, 3, 4, and you can call here 5. So this is simply 1I or simply I, 2I, 3I, 4I, and 5I. I denotes that this is the imaginary part of the complex plane. So when U is 1, V is 2. So this is line U, and this is 1, this is V, this is 2 for V, and this is 1 for U. This is where they meet. Is the point of intersection. You asterisk that point. Similarly, when U is 3, V is 2. So V is 2 when U is 3. This is 3 for U. This is also 2 for V. So you move and you locate these 2 points. Okay, you move and you locate the 2 points, the point of intersection. At C, U is 3 and V is 4. U is 3. This is line 3 for U. This is V4. You also locate the 2 points. This is 3. This is where they intersect. So you have something like this. So this is your point of intersection. You asterisk. Finally, at D, U is 1 when V is 5. This is 1. This is V5. This is where they meet. So you asterisk. Now you join all these points. Join these points together. Join these points together. Join these points together. Join these points together. So we have been able to what? Translate this given map, as can be seen. We've been able to translate it into this, what is there. All right, guys. So that's it on translational conformal mapping. In the next video, we'll start the rotational conformal mapping. I hope to see you in that video. Thanks and cheers.